So in a previous chapter, we learned about transformations of graphs and what happens to a graph based on if we add or subtract something to it, or if we multiply it by something, or if there's a negative in a specific place. Well, those all apply to exponential functions as well. Let's call this function here our parent function. We'll call f of x equals 2 to the x our parent, or our toolkit function, if you want to call it that. Okay, so if this is our parent function, look what happens when you add 3 to the function. Remember, if you add or subtract outside the function, it shifts up and down. It's a vertical shift. This graph shifted up 3 units. It used to cross the y-axis at 0, 1. Now it crosses the y-axis at 0, 4. So it shifted up 3 units. Well, what happens whenever you subtract 3 on the outside of the function? It will shift down 3 units. Notice how before your horizontal asymptote was y equals 0. When you shifted up 3, your horizontal asymptote becomes y equals 3. And if you shift it down, your horizontal asymptote becomes y equals negative 3. So that's your vertical shift. We also have a horizontal shift, which is where you add or subtract inside the function. When we say inside the function, when we're talking about an exponential function, that means inside the exponent. Wherever the x is, that's inside the function. So this is our parent, this blue one here. This is our parent function, 2 to the x. If we add 3 inside the function, remember that makes it shift left 3 units. Your horizontal asymptote is still y equals 0. If you subtract 3 inside the function, it shifts right 3 units. So notice we start with this one. It used to cross at 0, 1. If you shift it right 3 units, where does it cross? At 0, 3. It's not really crossing the y-axis, but that's where your 1 would be. So that's the point that you can use to kind of translate your function. So let's try this one using those transformations that we just learned. If our base function is 2 to the x, let's graph that one first. Let's graph f of x equals 2 to the x. Remember, it crosses at 0, 1, and we can just plot a few points just so you can see how it works. Let's plot some positive ones first this time. Let's do maybe a 3, 2, 1, 0, negative 1, negative 2, negative 3. I want you to see how this works. So if you put a 3 in for x, 2 to the third power is 8, 2 squared is 4, 2 to the first power is 2, 2 to the 0 power is 1, 2 to the negative 1 power. 2 to the negative 1 power is 1/2. Remember that rule? 2 to the negative 2 power is 1 over 2 squared, or 1 over 4. And then 2 to the negative 3 would be 1/2 cubed, or 1/8. Okay, so if we plotted all of those points, what do we get? We get 3/8. It's really difficult to see this, these lines over here. We have 2, 4. We have 1, 2, 0, 1. Negative 1 goes down to 1/2, and then we go to 1/4, and then we go to 1/8. So it's getting really, really close to our x-axis there. This is our parent function. Looks like that. So then what about the one that we're given in the problem? In this function, the -3 will make it go down 3 units. And then the +1 is inside. which makes it go left 1 unit. So we're going to take this graph, we're going to shift it left 1 unit. You see I'm starting at 0, 1. We're going to shift it left 1 unit, then down 3. 1, 2, 3. So notice how this graph starts at 1 unit below 0, 1. So we start this one 1 unit below 0, 1. Or in this case, -1, -2. Looks something like that. So what is our domain? It's still going left and right forever, so the domain is still everything. The range. Remember, we took this graph and shifted it down 3 units. So if the range of this red one was 0 to infinity, the range of this one is going to be -3 to infinity. Remember, we do not include that bottom line because that's where your asymptote is going to be. That is the equation y equals -3.